Okay, so I think we should start now. So before we start, I welcome Professor Shailendra K. Varsane sir, IT Kharagpur, for his very interactive talk. He's going to give the scope of optical networks in smart cities interactively. So basically, let me introduce him. So Dr. Varsane has joined the Department of Electrical and Electronics and Communication Engineering and Department of Physics in November 2008 as an assistant professor, and currently he is working as an associate professor in Department of Electrical and Electronics and Communication Engineering, IIT Kharagpur. He has also served as an adjunct faculty in the School of Electrical Science in IIT Bhubaneswar for 2015 and 2016. Dr. Varsane is the recipient of several prestigious fellowships such as Alexander von Humboldt, Germany, DAAD, Germany, JSPS, Japan, and Monbukangso, Japan. He has also received the Faculty Excellent Award in 2019 and GS Sanyal Award for Faculty Excellence in 2020 from IIT Kharagpur. Dr. Varsane works in the area of photonic technologies. More specifically, he is currently working in nonlinear fiber optics, optical sensors, optical fiber-based components and devices for next-generation communication technologies, optical wireless communication, including free space, underwater communication, and quantum communication. He has published more than 65 research articles in highly reputed journal and more than 100 in conference proceedings. So now I welcome Professor Shailendra K. Varsane, and now the session is over to you, sir.
Thank you, Amit, and I think all the organizing team of this FDP kind of like right. I'm the expert of fiber optic network, not the. Say my thoughts. I hope you can.
Yes, sir.
With related issue, switching off my video for the time, but I will sit on the video once again, and
Okay.
I hope you can see the slides as well. Right, all of you can see the slides.
Yes, sir. Yeah.
Okay, good. So first question that comes to our mind, since of course this COVID-19 a pandemic, this has also given certain opportunities in the other sense, though it's not a good, but it has given certain opportunity definitely, that we are now connected through the virtual mode a lot, right? And this is if you just ask yourself the question, how are we connected, right? WebEx, let's say if you look in, since this meeting is being organized by the WebEx, right? And if you look into it's kind of like where are the server locations. If you look into where are the server locations, if you find it, if you search it through the Google, of course, yeah, then you'll find out most of them are located in US, right? Most of them are located in US. So basically we are retrieving the information from such kind of like a data center where the servers are located. And what you see here is basically the all optical fibers interconnectivity within the different racks that you can see, right? That you can see this yellow one is basically, these are all the single mode fiber cables which are having for making connection from different rack to rack, right? Why I'm going to discuss all these, because these are the fiber optic network is going to be the fiber optic cables, or the fiber optic, let's say these are the basically going to backbone of your any kind of like whether it's smart city you talk about or anything which is related to smart, right? Because the data has to be transmitted, and the data has to be transmitted, that has to fetch the information, that has to collect the information from the servers, from the data center location. It can be local, it can be global. Can, I mean to say, that can be very far away or within your city, right? So this become very much important. So this is another way of a data center how it looks like. So you can see it's a very proper and nicely managed. So fiber fiber cables are kind of like going routing within the data center, right? And if we see into the next, like kind of like if I talk on to the next 5 to 10 years, what we are going to do, I think we are going to see that optical communication within the rack or within the chip is also going to happen very soon. And already several companies are in the, so we can see which will be very useful for designing or kind of like meeting the requirements for smart cities. So if you look into certain data center locations, let's give an example of, let's say, for example, Google. And if you see that these are basically most of them are in the US, and they have now, I think recently they've been started in Mumbai, and future they are planning into the Delhi as well. All right. So I'm sure this must have been touched upon by, I think, various speakers and different experts. But if you look into the internet connectivity, that how we are connected, if you're sitting in the different locations from the, let's say, within India, somebody from the south part, somebody from the north, somebody from east, somebody from the west, right, at different locations. So some of you might be connected through the mobile hotspots, or somebody will be connected through the most of you, I think, I think most of you might be connected through their mobile data, right? Mobile internet connectivity, right? So as we are getting more large number of users are getting connected, so the problem of the bandwidth is going to be here. The kind of like a requirement of the bandwidth is going to be large, in the sense that we need more kind of like a bandwidth, high speed, right? So that's, if you look into the evaluation into the different telecom, I think I will touch upon. So it means, let's say right now I'm somewhere here, I'm somewhere in the eastern part here, I'm sitting here, and then this information is going to the WebEx server. WebEx server is one, it is one locally, it is present in Bangalore, somewhere here. So the information is traveling to the back and coming back here, right? So it's happening like this way. So server are located somewhere else, and we are getting connected virtually. So if we look into the Indian perspective, so I think let me come back to this. I think it's better. I think all of you can go and have a look onto these two websites, where you can see in more detail onto the how we are connected through internet worldwide. You can go into the website. You can see the live also feature what are the lines. So if we look into the more detail, so these are the some just picture shots from here. So if you look into the Mumbai, so basically in India, there are basically two internet gateways. This international gateways. Basically, one is located in Mumbai and one is Chennai. So most of the landing stations, so most of the lines, these lines are nothing. These are 5 optical cables, which are that's going through the sea. And right, and so going to the different. So these are landing stations. So there's the hub is Mumbai, and another is Chennai. And other than this, there is again the small. In the Kerala, there is a small kind of like again the landing station, but I think less number of cables that terminate at this point, right?
Excuse me, sir.
And
sir,
yes.
I think your slides got stuck. It is on very first slide.
Oh, really?
Yeah.
I am on to the.
Yes, now it is 5th one.
My God. So just let me know, please, all of you, just please let me know if it is getting stuck, right? I know this is some problem is happening. It's a bandwidth, some issues is there. So anyway, so I was talking about how we are connected. So I was on to this slide. Are you able to see the map of India, Mumbai?
Yes, sir.
Yes, sir.
Okay, good. So please, that will be good if we just keep on talking, so that I know where I'm right now. So basically, one is right. So one is in Mumbai, you have, and the other one is in the Chennai. So we international gateways are the two locations we are international gateway. Other than this, some in the Kerala, and I think one is also in plan to be in the somewhere into the eastern part as well here. So recently, I think you must have heard about the news that a few months back there was cable has been cable has been laid between the Andaman Island and to the Chennai. So this has been recently, I think, was also it was becoming functional, operational. So there's another line which is there. So if you look into any of them, if you just click onto any of the link, let's say that goes through the Europe and then reaches to here, so you can see, probably you can see also who owns this, kind of who has some owners. So you can see from the India side, you can find out certain names, definitely Airtel, BSNL, and so they owns a certain portion into this cable. So physical cabling done by the some other companies, basically they shares, in the sense it generally it is given the lease, right? So whether it is, let's say, from Mumbai part, it goes to different landing station, and how we are connected, right? If you look into the within India, is a Railtel, which provide these connections within India. So you can see the map of. I am on the slide number 6. Can you
Sir, it
see?
is not moving. Fifth one is showing. Yes.
Okay, so I'm on the right now slide number 6. So here it is, if you look into the right hand side, is a map of railway network within India, and this is how the optical fiber cables, because most of the cables has been laid across the railway line. So it looks, because the Railtel is the company, so it has basically the physical infrastructure. And if you look into the slide number 7, right, so this is I just like to ask you onto the slide number 7 on the right hand side here. Right, so this is a WDM network of the Railtel. So you can see, basically in India we employ the two. Basically, one is the SDH network, and one is your Railtel, sorry, WDM. So as like is Railtel is a company. I mean, like technology wise, is one is a synchronous digital hierarchy network, and one is a WDM network. So it's all optical, whereas a Cygnus SDH is basically is in a hybrid, in the sense is in electronics, it has electrical plus optical both, whereas in a WDM or DWDM network, it goes on all optical. So basically, still we go ahead. I have to go like this way. I think there's some issues with this right now. So I'm sorry about that, but I have to go like this way. So I have to go every time. I have to escape from the PowerPoint mode and have come back, or I can just go like this if it is fine for you. So this is what I was saying. So for SDH is 1664, when the 10 Gbps line, 0.5 Gbps line. Like in about IIT Kharagpur right now, we are in the 10 Gbps system, 10 Gbps system line, whereas you can see certain lines. Of course, the pink one is a 1664 is a 10 Gbps line. There's a blue one, and certain location in India 16 STM 16. This is basically nothing. This is a terminology for realizing SDH. So this is basically in India we have both WDM as well as a SDH network, all optical. So I'm just giving you right now an overview of the network. How does it look like, and how we are connected within an India. So if you look into, so it is Mumbai, and I think somewhere is the Chennai here on this side. So all the international connectivity goes from here, and the one and the goes from on this side. Right. So and when you look into the user side, so is this basically you are connected, whether it's a fiber is coming to your home, or whether it is whether you're having a connecting through the mobile. Thus you're having you can see the towers which are there, and they are connected to some certain switches. So basically SDH switches. Sonet we don't use in India. We basically the Asia Pacific region, we use SDH. Sonet is big basically in the US and the North Canada, or North America, I would say, not Canada. I would say North America, that includes the Canada, but rest of the world is basically SDH, and then is connected to the core router. So that's your, let's say, this is within, let's say, in India, and this is going to international connectivity as well. Regional can go to the core and the backhaul. So as you know that as the things are, the all telecom operators or as telecom companies are pushing towards the 5G. So the 5G, basically you are going to have a high bandwidth, high bandwidth in the sense that if you are having a 1 Gbps at your mobile terminal, that's but there are a lot of challenges to realize this. That's so how to go ahead. So whenever if you look into the mobile, let's say, so whenever you look into the tower, what's happening? Okay. Just hold on. So when you look into the kind of like for the mobile, I know how I can draw it right now, but let's say tower, which is there. So right now we have the all the not the fiber, but soon the fiber is reaching to the tower. What I'm saying to you, I would like to convey the message that now fiber is going to reach to the tower. That's something onto this side, kind of like this. So if fiber is going towards here, then you have the antenna, and then so going to connectivity is going between the antenna and to the fiber. Basically, it was before it was on a cable. That's an electrical cable, copper cable. That's why going till the your central office to the, let's say, telephone exchange, right? But with the demand of this, as you go for ahead, so fiber is going to play a very important role, whether it's a smart city you're talking about. So means like to realize in a smart city, what do you need? You need a very strong kind of internet connectivity or strong bandwidth, because many devices are going to connect simultaneously. You have to transfer the huge number of info, a large amount of data is going to be transferred between different nodes. So you have to have proper management. So, and who can handle this? So fiber or only optical fiber cables is possible to do it. So the concept of FTTA, fiber to the antenna, is coming up. So where the fiber is reaching to the antenna. So that's why I was mentioning. So if you look into the your distribution side, so this is some I have taken from the from within IIT Kharagpur network. So one of the location I have taken. So how you are connected. Let's say how we are connected. Let's say not you. Let me give an example. For IIT Kharagpur, IIT Kharagpur basically is all fiber network. Everywhere is all fiber. So even our two houses, we are having a all fiber connection. So our house is basically having this kind of a unit. This is something like the same. So I just taken a original picture. You can see the yellow color cable which is coming to the box, and this box is which we call as a optical network unit. I think you must have heard about into the GPON on the top during that one. So this is how the unit looks like, and then on the unit the fiber comes here, and then there is a backup for the battery backup for this device. And then you have the four or five Ethernet ports. The one is for the four data ports. Let's say two voice port, and one might be video. So it's possible. So that's at your user side, at a user side. But intermediate point, if you look into this one, so basically find out there's a kind of inlet, and then you have the that goes, and there is a kind of like a 1 by.
So the slides are not changing, sir. It is on ninth one.
Basically, if you look into the India, who basically the manufacturer plus kind of like they are also deploying the optical fiber. One is that name that comes with Stellite. Basically, is also a fiber optical manufacturing company. Also, they are also deploying the optical fiber cables at the different kind of within India, outside India. Of course, they do export, but within India also they are deploying the optical fiber cables, right, for the better connectivity. Ox Optifiber is another one.
So
And
slides
this
got
is
stuck again, sir.
sorry.
It is on ninth one.
My God. Did you hear this? Did you see this?
No, sir. Now we are seeing it.
Okay. So please, Amit, just or some other audience from the saying to me. Anyway, so okay, I talked on to this. I mentioned that this is a network for IIT Kharagpur. I've been talking about not network. This is how we are connected in an IIT Kharagpur system. If you look into the, so this is one unit, optical network unit, which is located in our houses, and you must have heard about this in during the GPON talk. And if you look intermediate point, and somewhere the fiber comes here, and then if I open the box, then there is a splitter which is there, right? This is kind of like a power splitter. So this is all passive device. So it is right now is a 1 by 8 here. So it means we can connect to the 8 users into the nearby, right? So just want to give you the glimpses how would it look like. And next one is I think this. So basically about this Sterlite, about the who manufacture Indian company who manufacture the optical fiber cables, and they deploy in within India as well as export as well. So one of them is a Sterlite, as well as another X Optifiber. I hope you can see this. And
Yes,
there is
sir.
another company with the Furukawa collaboration, and this is Birla Furukawa. So they are basically these are two, let's say these are Indian, let's say, manufacturer Indian company who manufactures this optical fiber, and they deploy as well. So I come to the basically now, I think, to this portion of my talk. So basically, fiber optic network's role in building smart cities. So basically, this image I have taken from the fiber locator. This is some website. So just only the presentation. So how does a smart city going to be? So basically, it is going to be transportation, services, healthcare, smart buildings, smart electricity and water distribution, smart surveillance, smart infrastructures. So everything is going to be connected. With the backbone is going to be your optical fiber network, right? So these are some of the features. So, and the another key component here is going to be the sensor is going to be ubiquitous, and it's going to be a lot of huge amount of work has to be done into the sensor side, whether it is a whether it is an air, let's say, pollution monitoring sensor, right? Or whether it is a self-driving for the sensor for the self-driving cars within a city, or is a kind of sensor for developing kind of like for the water distribution, smart meters for the checking out the pipeline leakages, etc. Is smart surveillance is surveillance that includes now whether thermal, because now is I think most of the time, not most of the time, I think many people they they install the cameras, right? Those are the thermal cameras into their homes, like they to monitor the things, and they get the information what's happening there in their absence, right? They can monitor where they are through the internet connectivity. So that's a smart surveillance, a smart infrastructures, of course. So that's a smart infrastructure that can include your the roads or pathways. It can include your the buildings, smart transportation, of course, and services, right? So the different components of a smart city. So since each and every has a huge kind of like a kind of like one can discuss a lot. So is all kind of like how we are going to create, if you look into smart healthcare. So basically my point is going to be discussed onto the, you're going to integrating the different data information, whether it's if you look into the smart healthcare, for example, if you look into smart healthcare, right now as the time is progressing, everybody's probably most, I think in next future you're going to have wearable electronics that have integrated sensors, it might be, right, that can monitor your health status, and send the information immediately to the nearby and that node, and that can go to the your data station, and then from there it can be collected. So data station, basically those are the clouds in the sense of physical data center locations, and it can be your, so this is going to be huge amount of role is going to be play by the management other than physical infrastructure. The data, because it's a very complex and dynamic system, is going to be, so basically is going to be managed. Management is very much required. So if you look into this, so how the optical fiber network is going to help you, right? So I think I am not going to the detail onto this historical side. What I would like to mention onto one side as well, onto I'm on the slide number okay, 13. We go for smart cities, security is going to be concerned, right? Security is going to be concerned. Somebody should not be, let's say, some third parties should not have the information, right? Should not hack or manipulate the data, right? Specifically when you are connected the different kind of like a services within a smart cities. So basically it may happen in near future your this quantum communication may come up, other than the providing a, let's say, algorithm based security, but quantum is going to play an important role in the near future, right? So I think I'll skip this historical part. So I think all of you might have heard about this optical fiber evolution. We started the journey in the optical fiber with the multi-mode optical fibers. So I'm on the slide number 15. So we started the journey with the multi-mode optical fiber, and coming back into the same once again, not for distance communication. But for short distance communication, we are again thinking for using multi-mode optical fiber because of it. Not multi-mode, I would say few mode fiber that has not the single mode, but few mode fibers for providing you the higher speed. High speed basically in the sense, or let's say more bandwidth to meet the bandwidth requirement. Basically, the information is going to travel in terms of the large number of modes. In case of like instead of single mode fiber, so basically all information travels in a single mode, like a Gaussian, right? So this is your backhaul is going to be like this always. Your the internet connectivity with submarine cable or this basically going to be single mode fibers on the long range network. But in case of less short range network within a city or within a possibilities that we are going to use the few mode fiber once again. So people are looking this solution because now you can multiplex the signals into, let's say, whether it's a LP01 mode, one of the Gaussian mode. Yes.
Slide again got stuck, sir.
I am onto the slide, same slide, evolution of optical fibers.
No, it is on, yes, sir, 15th. Okay, sir. Yeah.
Yeah, I'm here only. I'm onto this slide. I hope I'm writing you. Oh, I hope you are able to see. I'm writing here
it's
on
not
screen.
Visible, sir. Not visible.
Yes, sir. Yes, sir, it is visible now.
Okay, sir.
It is visible now.
So there is a delay. So now you can send the this morning you heard about this latency, right? Morning you heard about the latency on top.
Yes, sir.
Right. So this is going to be one of the challenge. So when if you're planning a smart city, so if there is a delay of let's say few of tenths of second, people may also die. A person who's having some heart stroke, right, and the sensor is not able to, or the network is not able to support the data immediately, information not retrieving, the person may also die. So it's a huge challenge. So what I am saying, I'm just as a joke apart, that what I'm writing is taking some few seconds. So there is a delay of few seconds because of the band congestion or the congestion onto the network, right? So how do we overcome though? So because there is a huge, everybody is connected virtually right now, so the bandwidth requirement is going to be very high. So the challenge is next few years, people have already started working to creating a devices and see can we use a few more fibers that may support, let's say, modes, and then encode the information into the each and every these modes, whether it's LP01, LP11, or LP02, right? So all kind of like a modes that we can employ. So that's good for the short range communication. Definitely it will help. It will help you into the 5G or the next generation communication as well, right? But is not suitable for the long haul. For long haul, definitely we are going for single mode fibers, right? So if you look into specialty optical fibers, these basically are not yet not very kind of like a promising candidate, though for the certain application yes, but not for communication yet. People are trying to look into the hollow core photon crystal fiber as an alternative for as in a substitute for communication because of its light is going to be guided in air. So it means it's going to have very less interaction. There's no, of course, the minimal interaction, say no interaction with the material. So it means losses will be negligible. So you may not require any amplification. So it means signal is not going to broaden over the time. So the delay won't be occur, pulse delay won't be there. So it means you do. So there are many advantages, but still there is a challenge to draw these fibers in long length. So long length is one of the issue. Price is one of the another issue. Second, third issue is basically right now, the losses are between 1 to 1.5 or let's say nearby 1 dB. So which are not still not at the level of the single mode fiber. The losses are 0.2 dB per kilometer, right? So basically the losses are still high. So but in future definitely if this is possible, then they may replace the optical network might be replaced by this hollow fiber. Sorry, most of the fiber net they may replace by the hollow core photon crystal fiber in near future. It may happen, I know when, but is definitely. So other than this is going to be another category. It might be very useful, especially for the sensing, because here most of the atmospheric signatures are lies into the mid infrared. That's between 3 to 5 or 3 to 7 micrometer. Then these fibers might be used for creating a devices. Out of these fibers might be useful for especially sensing into those regions. in the air pollution monitoring and several others. Right. So I think all of you must have heard the why optical conversion. I'm not going to discuss this, so like to just have a focus onto this portion of the slide, on the where shown in the bit length, or let's say transmission capacity on optical fiber versus ear, and which you see here. This is I've taken from I forgot to put the reference. I've taken from the paper by the GP Agarwal, and review paper. So I think it's a GP Agarwal one. Last moment. So basically this is right now we are here in WDM. I think already I mentioned to show it you into the one of the view graph. We are using it, and what's going to be happen, because the bandwidth requirement is very high. So a spatial division multiplexing is one of the solution. Spatial division multiplexing or hybrid, in the sense WDM plus SDM together. So a spatial division multiplexing, as I mentioned to you, basically these are having a few mode fibers. So you are launching you are encoding the information different modes of the fiber. It might 4 or 5 modes. So you are multiplexing a single wavelength. So you have one wavelength, but you have single lambda, but you are having encoding the information, let's say in LP01 mode, LP11 mode, LP, let's say 02 mode, LP21, for just to give an example. So it means once you have this kind of a multiplexing you can achieve, you have one information going here, second, third, fourth, and this is one wavelength. Then you can have another wavelength, lambda1, lambda2 also you can do, and then so it means you can enhance the transmission capacity further. So that's for the long distance, as I mentioned to you, because of the dispersion will be so only for the short range or less short range network it will be quite useful. So come to the application of optical fibers. I think already you're aware on this. So basically it can be used for video high definition television, for first choice for high definition television, sending the augmented reality. As you go for ultra high density videos might be possible. So that's going to be a feature in the smart cities, intelligent transport systems, smart highways with intelligent traffic lights, toll booth, and so on. And this is some application to the healthcare, and some application in kind of space and defense and industrial sector. So it's going to be a huge application of the optical fibers. And another point I'd like to have your attention is onto the right now our communication is centered into the this band, basically here. So we are right now on somewhere here onto this band, C band, that will communication band, we call conventional band. So 1530 to 1565, but people are exploring some onto the O band and slightly E. So if you look into the losses are still high, but I think it's possible to now do the amplification. So it might be, so people are looking, can we move slightly onto left or slightly right side? So also people might thinking to move slightly onto the L band side, I think already. So up to 1610, and after that, of course, the fiber has become very, very lossy. The glass material become lossy into the, if you go further into the on more than greater than 2 micrometer, but these are the most suitable band. So people are exploring alternative bands as well. So O band is going to be one of the promising for the telecom applications. Right, I think I have not talked on to the types of optical fiber. I think you have already heard about it. So I would skip this portion as well. If you want me to discuss, definitely I would be happy to discuss onto the dispersion and other things. So let me come into the onto this part. I am onto the slide number 24.
Yes, sir.
Right. So to create any kind of network, right, or like communication link, what you need it is basically transmitter. You need an LEDs, light emitting diode. So for short range applications, so that can be used for the, let's say you are in a building, smart buildings, you are going to put a transmitter. So that can be it can be your transmitter, the capturing the images, right? So and then processing the images, transmitting the information, right? Laser also again is can be useful, but it should be eye safe range, because all optical wireless going to be other than your, of course, the network in the fiber based system. So its own pros and kind of like there's own benefits and kind of like of course advantage and disadvantage both. But if you look in terms of the fiber based network, we use basically laser dye as a for long distance, for high speed and long distance communication, and LEDs have been used for the creating a short range or local area network, right? And this is a cheaper option than the laser dye, but it cannot be upgraded it cannot be upgraded in the sense that, because with the LEDs you are going to use basically multi-mode fiber or something like this, but it's always better to use a single mode fiber in one goal if you are trying to go for high speed network in near future, right? And look, channel, if you look into the channel, so basically is a fiber for the suitable, as I mentioned to you. And this is the most important part, is your receiver design. Basically the how sensitive is the photodiode the device is it, right? What is the sensitivity level of the, whether it's a pin type photodiode, or basically for the long distance we prefer to use the avalanche photodiode, where the sensitivity is very good, but it comes with a noise. So once the signal is converted into the electrical domain, so the role of the electronics come here, so which is basically signal processing, signal conditioning, and signal processing. So whatever the network you design, so it's basically completely kind of like, I would say, is limited by the receiver in the sense receiver performances, right? So depending on to the selection, you're creating a good receiver. If you have a good decision making circuit, very sensitive, can detect, let's say this photodiode can detect minus 50 dB, minus 60 dBm. It means I can go for the much longer distance, or I can go for high data rate. So this totally depends your all optical let's say communication link or the network basically is his performance is basically determined by the receiver performances. So that's the most important part of any communication design link. So now as I mentioned to you, so is possible two possibilities, where is a wired, so which is your, let's say, wired, but let's say in a home you have several devices which are connected, right? So it's a wireless basically. So one option is we have heard about a lot of kind of like let's say in every house I think there's a Wi-Fi router, and you're connecting many devices other than if you're mobile, you definitely a mobile phone, but nowadays you must have seen about the smart bulbs, right? Even other than the smart bulbs, bulb means like lighting, so you can change the different colors depending on the mood and other things. So it plays in a very much important role, of course, onto the sleep pattern. Many things are there associated with it. So other than this is your now also possible is having a smartness into the refrigerator. So I'm just giving certain examples, right? You have the certain devices, let's say Alexa is again Wi-Fi connected, right? So all the devices are going to connect to his requirement the bandwidth, and then finally the information has to be traveled by the optical fiber, through the optical fiber. Now in the wireless, there is going to another route which is to be optical wireless. So basically, which we call as an Li-Fi. Li-Fi, this is within the home. It can be outside, plus within house. So it can be in kind of like internal, or then can be external connections. So external is something like an example of having smart lights, smart traffic lights. So basically, there's nothing. This because it's all LEDs, so you can modulate, you can do the signaling, you can make the connection between and most of the cars also, or the vehicles, they are having now LEDs lights, so it means there can be communication between those. So it can be a intervehicular communication. So it means you are going to create. So basically this is going to be very much important. This area is going to be a huge important, considering the development of the, let's say, smart cities. In terms of I'm talking about the term transportation now. LiDAR is a laser based kind of like imaging, like a radar. So radar is your micro version. So LiDAR is basically now you're working in optical, so it's a terahertz frequency range. So basically for the imaging application, this can be a quite good alternative. People are trying to, let's say, whether you look into the self-driving cars, so LiDAR is going to play a very much important all the wireless. So another component that can be added into the wireless is for the underwater. So underwater, basically, whether the communication between submarine to the, let's say, the ground station, or between submarine to submarine, submarine to the divers who go there. So that can be again, that's going to be again optical wireless can be, because there is a jitter in case of course, whatever do into the microwave range is still there is a jitter in the, because sonar technology being used. So, but in case of optical wireless, so this is an upcoming field in this, let's say, optical wireless. I would say that is a kind of like a upcoming, or let's say, research front where we need to do a lot. And of course, in terms of the security, so whether it's right now we use all the algorithms, so based on security, where we receive OTP, but in near future is going to be a quantum. So basically the security is inbuilt. So this is another form of communication is going to happen soon. Regarding Li-Fi, so this is Professor Haas, who has actually given this, started with this idea of the creating a kind of like modulating the light bulbs. So it's simply white LEDs. So it's an array of LEDs. So you can modulate and pick up the information. So it can be useful. Specifically, can be good for this Li-Fi concept. Can be good for, let's say, in hospitals, where you don't want that this should be kind of like any should not be any interference between the equipment which is monitoring is a few percent health or something like this. When a person is, let's say, doctor is doing the operation, that time if you want to see, he can do the internet connectivity using the Li-Fi instead of using a Wi-Fi, because if you are doing that, then there is some kind of instruments interference would not be there. Can be good for the choice for the within the avionics sector within the, let's say, within the aircraft. It can be a kind of like communication between the within the aircraft. So this can be a lot of use possibilities. There can smart cars, vehicle to vehicle communication, as I mentioned, to leader underwater. So this is showing certain kind of, but a lot of challenges are there. This is non-line of sight is not possible for here. Non-line of sight means in the sense that here a smart LED lighting, so generally we place at certain distance on the wall or not on the roof, for example. But if the person is somewhere here in somewhere here, he or she may not have access to the internet connectivity. So the non-line of sight is one of the challenge in this case. Of course, I think people are working still, so whether we can go. So this is a kind of like a secure network. A person cannot access because is not going to be accessed by anyone else outside. So this is onto Li-Fi, and if we look into network onto the, I think I'll skip this part. May not be, if you want, I can talk on this. Else I will skip this. What I want to say onto this side, that other than Fireway system, optical solutions are coming for on chip, because on chip is going to be kind of like creating kind of like all optical solutions within the chip, which is where you have the copper interconnects going to replace with this optical interconnects. So I think I'll skip this part. So this is, I think, if you want to, we can discuss definitely. And okay, let me come back to this one. So what are the requirements? So for a smart city, right? In terms of city, what are the requirement? So one is enhanced mobile broadband. That's providing peak data rates. 10 Gbps is really too much futuristic, but still, if we can get it 1 Gbps on a mobile phone, I think it's going to be very good. So, but this can be realized only when you're having a fiber. Of course, is the antenna from the, let's say, RF, right? This is going to be an RF from the antenna to, let's say, the users. So in that case, the users has to be very in close vicinity. Of course, the power, that's again challenge. I think people are looking. So that can support such as emerging technology such as augmented or virtuality ultra high density videos. Another one factor which is going to be play important role is ultra reliable low latency communication. So it means you need to have really 100%, but there is still, I think there is a latency always is there. Right now, what you see, there's a latency when I'm writing or doing something onto screen, and you are seeing after a certain fraction of seconds. So it required to track and control autonomous vehicle as well as everything else in their vicinity, including the cars, bicycle, pedestrian, construction site, and even trees. So that has to be there. So like self-driving cars, so right, if we are there, there's some jitter is happening, some latency is there, then is I think is not going to solve the purpose. Reliability and quick response will be also vital for devices such as home and medical equipment, right? So though we are moving towards a smart city concept of smart cities, but it's a lot of huge large number of challenges. This is another point which is to be there, massive machine type communication. That's basically you are connecting each and all your devices, electronic devices through IoT basically, and family of devices expect to proliferate to densities of hundreds of thousands per square kilometer. Everyone would like to use it, right? Suppose you are a user and like to have the definitely smart refrigerator. You want to have a car which you can control. I think there is already, we can see certain advertisement in the from the car companies, some automobile, that you can start the car from a home while sitting. You can switch on the AC while sitting at home, and so the car is just ready and welcome you before you enter into the car. So it means this is an example of one device, so it can be several within the house. So that's a one person. So now I can understand the kind of like a data or volume of the data which is going to be generated, and this has to be transferred, communicated to the different locations, right? So this is what else is going to be. So I am on slide number 34. So another one is going to be your sensors, which is going to be a key component in smart cities. So in this case, we can have basically two things. One is your electronics base. There's electronic sensors, and another one is your optical sensors. I hope you can see on slide number 34, right? Hello?
Yes,
you can
sir,
see slide 34?
Yes, sir.
Okay.
But it is still
Yes,
blank.
So another one is your optical sensors going to be. So basically, even if you have the electronic sensor, so the information that has to be again transmitted in form of, finally it has to go through the optical fiber, right? So there's a huge kind of like a scope for all the community to develop, really, to have a kind of like a optical sensor which must be sensitive, but can be used for whether different applications, whether it's for the medical, for the healthcare, or it can be for, let's say, for architecture. Of course, we generally the buildings are the health monitoring of the buildings are basically done by the fire optic sensors basically. So medical is one you can have, and I think there can be for sensors, lidar, as I mentioned to you, for the self-driving cars, of course, and I mentioned to you for less air pollution monitoring, environmental.
Sorry, sir.
Yes.
On slide number 34, we are unable to see anything because it looks like a blank PPT only.
I'm writing on two slides same. I am writing it.
Okay. So it will come after some time. Okay.
So let's let if it comes.
Yeah, it will, sir. Yes.
Are you able to see now?
Not yet, sir.
Okay. There's a delay. Are you able to see?
No, sir, still not, sir. Yes, now it is visible.
I'm sorry, Amit. I know why this problem is happening today from my side. I have to just. This is a issue with, I think, as this should not be this kind of like issue. I know this might be hardware problem. I think so. From the laptop
Yes,
side, might be hardware problem or the bandwidth. So it looks to me hardware problem from the computer, not the network. But anyway, because if I'm just switching on, like going from the slide mode, it is what it's seeing, right? So as I mentioned to you, so sensor is going to be a very key component for developing a smart cities. So of course, there are electronic sensors are available in the market and people are developing, but optical sensor is going to be play a huge important role. And the advantage is going to be that since it's going to be a fire-based system, or either it is a fire-based or it is let's say chip-based. So either of these, so is have a better connectivity. Connectivity would be your, in the sense with the existing network. Connectivity in terms of the existing network will be better. I hope you can see what I have written now. Right. So connectivity in terms of the fiber, because if it is all fiber based, then it's easy to make integrate with the existing line, with the existing fiber optic line. If it's chip based, also is possible to tape out the information through the fiber and then connect it. Right. So there's a huge scope is there. That's in terms of the, let's say, in medical field, air pollution, water line monitoring, or water, or let's say pipeline monitoring. I would say pipeline monitoring, and whether it's security, surveillance. So surveillance, of course, we have the cameras, thermal cameras, but that's again, there's no thermal cameras are there, but still security is one of the, so where you can have a distributed sensors. This can be your distributed sensors, which get the fiber with the, along with the fiber. So this is basically fire-based distributed sensors. Might be one issue, one possibility, and that can give rise to the like you can monitor kind of like a movement of the peoples. You can monitor the different kind of movement is possible. So this is sensor is going to be a key component. So I would coming back into the same slide. The question remains again to the whether you need to have a low latency, ultra level low latency. So in terms of basically the management. So basically this comes from the management other than the hardware. Of course, the hardware has to support, but there is some basically in terms of the bandwidth management, the connections, how we are going to use those information. So this is some just on a view, small, I think the view graph onto the how these are connected. So you can see the role of the fiber everywhere. So role of the fiber is everywhere into the from the tower to the fiber to the antenna, then to the office. There's a telephone connection to connect it to the regional network, which is this basically can be your SDH or WDM, and then finally it is connected to the again with the DWDM or SDH or global network. So this is, if I would be happy to, let's say, have a more interaction now. So regarding I have skipped many things, so I thought to have a more on interactive and discussions. So let's have a interactive discussion with you all. So that will, I think, help us.
Okay, so thank you, sir. So actually, I would like to say that
I have to write about my group, but I would say, let's say, I will just keep it at the moment, and I will resume once again. So let's have a question answer right now.
Okay, sir. Yeah.
So, kind of have a discussion. I would say question answer and a discussion. Maybe if you have any queries related to anything onto the fiber, onto the network, or not network, I would say fiber and communication. Just let me know devices, expectation, everything.
Okay. So, sir, I would like to say that the people are listening the optics, photonics, optical network from last 4 to 5 days. But I think you have delivered the best what the people are looking for, how they can integrate what is the role of optics or optical networks in the smart cities. So there are very possible ways or opportunities of optical networks or optical communication that plays an important role for developing the smart cities. So now the participants, please, are want to interact with you. So if you have any questions related to that, then please ask. And I also have some
please feel free.
Yeah.
Please feel free to put up the questions. I will try to answer at the yes.
Yes, sir. Myself, Jayesh Prajapati. Sir, just I would like to know something about the few mode fibers, whatever you have just talked about, like single mode and multi mode that we know.
Sure. And any other questions? So then I can club and 2 or 3, then I can answer.
So that is all from my side.
No, I feel like other people also, other participants also, if you have any questions. Hello,
yes, I'm having
other participants.
Some questions I'm having that is related to basically the smart cities. So I'll ask later.
Okay, we can keep it later on. Yeah, let's say from the participant Amit, some other. I will explain few more fiber definitely, but any other queries? Role of PCB in smart cities. Okay. Okay, and what else? Data science. Okay. Okay. So 3 and some more questions. Okay, so let me go back to here and I hope I can see the blank slide right now. You can see the slide?
Yes,
37.
sir.
Okay,
Yep.
good. So basically few mode fibers means it's the fiber which can, since our communication is at 1550 nanometer, right? So the dimension for that fiber which supports this is 8 to 10 micrometer core diameter. So which we call basically single mode fibers that support only one mode, that's your LP01, looks like a Gaussian or something. Like if you look into the intensity, if like this, if I take a cross section across, it looks like a Gaussian, right? So it means if I slightly increase this, let's say core diameter, let's say 16 micrometer or somewhere, then it means I'm allowing more modes to add this wavelength. So what I mean to say by the number of modes here, so that's the reason I have put up the information on this side. So mode means kind of like the mode which makes a kind of like a, let's say, zero angle. Let's go along the axis, environmental mode, and the next propagation possible is let's say one more angle. So that give rise to the kind of like a next higher order mode, in the sense that it can be your basically the LP11 in terms of the communication, in terms of telecom communication application, right? Okay. So what is it I mean to say here? So it means you are simply using the core diameter of the fiber. Let's say it was 8 to 10 micrometer. This was let's say the single mode fiber, this, and for case of the fiber, this might be this core diameter. I'm just giving a core diameter. So it means this can support you now LP01, LP11, LP02, LP21, and so large number of modes. So basically this we decided by the V number of a fiber, which is 2 pi by lambda A multiplied by numerical aperture. So it means this is a, let's say, wavelength is a fix, and so it means, let's say, what else is the parameter? So NA is here, and number of modes basically is for the step index fiber basically approximately by 2. So it means I'm just increasing this V number. So it means I can get the large number of modes. So the mode is basically nothing. This is energy distribution within the system, right? So the energy distribution, something it may happen like this. And next distribution, this LP01, this can be your different polarization of this. So one polarization like here, one polarization here, and then LP02 is again you are having. So it means what I mean to say here. So if you have the system, right, if you have fiber, let's say from the data center, let's say from your home to, let's say, some antenna here, right, from home to antenna. So this is basically going to be a few mode fiber in near future. It may happen few mode fiber because we are talking about 5G or 6G, where the speed is that you want to have a high bandwidth, right, or high speed, let's say, data rate. In that case, we can do the multiplexing. That multiplex means I can send the information, encode the information L1, I can encode the information LP11, I can encode the information LP02, I can encode the information LP21. So it means I'm just simply multiplexing all these. I'm just multiplexing all these with the mux, with the multiplexer device. So this mux has to be different. This multiplexer cannot be wavelength multiplexer. This multiplexer has to be your mode multiplexer, where we are right now working in our lab. We are trying to develop this all fiber based multiplexer, this device is specifically. And then you are having a fiber is your few mode fiber, and the same at the other point you are going to have demux. And then once you have information, you are going to just use the your further photodiode to pick up the information. So this is about the few mode fibers. The second question regarding the PCF, Regarding the PCF, yes, in terms of the smart city, can be for sensing, for the sensing only. That's only one application. Another application can be your creating a sources, especially kind of like a super continuum. Be useful for kind of like a super continuum in the sense you have broad kind of like a broad coherent source. Broad coherent source for the all the wavelength range is possible. That's because of super continuum. So source is possible to create a sources using a PCF. And another one is using PCF. Another possibility is that create a sensors. So that's that may have a role. And another point was onto the machine learning or the data science. This is going to play an important role in the sense you are specifically making connections or routing the information, basically for the routing and protocol. Other than the it can be good for the device performances. To optimize the device performances, we can use the machine learning algorithm. So people are trying to optimize, let's say, transmitter performances using machine learning. People are trying to find out the EDFA for amplifier, trying to use the machine learning. And of course, because you have the connection. So when you will look into any network, right? When you look at, let's say, any network, if I take a kind of like a mesh network, let's say, so trying to make, let's say, how the informations go. Let's say you want to make connection between this to this. Can we make it more effective, much faster, or let's say without having any at this intermode, add any kind of wavelength conversion is possible to have or not. So basically, I think the machine learning is going to also play an important role on the data science here. Other than this sensor part, yes, let's say machine learning may also be useful, especially in the having a kind of like identification. Let's say predicting the let's say events based on the information which has been gathered from the network. It can be sensing. You have a multiple, let's say, sensor are there which are at the part of smart city, and when you want to, let's say, diagnose, right, let's say you want to see which one. So I think this is going to play a role there also. Yes, so other questions? Am I clear?
Yes, sir. So some more questions from participants that is in chat box. What is the expected data rate for smart cities?
Yeah, see, we are struggling at 10 Gbps, right? We say in IIT Kharagpur we are getting 10 Gbps in our CIC building. That's your office. From where then you have distribution, right? When you talk about smart city, can get Gbps going to very good, but it totally depends on number of users, hardware infrastructure plus number of users which are there.
Yeah. Yes, sir.
Right. So what is the scope of optical network image compression encryption techniques? So image processing is this is not going to be an optical in the sense. Maybe in future people are exploring about the quantum. So quantum in the sense quantum imaging. This people are trying to explore. I am not sure about the encryption. Basically, is going to be on quantum. Basically, quantum mechanics principle. Traffic grooming. I hope I think. Give that answer.
Okay. So, sir, basically, we are hearing lots about the smart cities for the last 4 to 5 days. So, sir, actually, what do you mean actually by smart city? Hello.
Hello. Yeah. There's some problem. Now I am audible.
Am I audible, sir?
Yes. Yes.
Yeah. So, sir, actually, my concern is that the people are listening lots of about the smart cities for last 4 to 5 days. But what actually do you mean by smart city?
Actually, as I think, let me go back to this slide. Okay. Here. Right. So as I give, so what a smart city looks like, you have all the services. all the kind of like at let's maybe automatic, or it might be whether it's healthcare, as I give an example, smart buildings, smart electricity and water distribution. So that may be kind of like on the grid and the water distribution, smart meters, whether water is required or not, or maybe kind of a household applications, smart surveillance. You're picking the information, let's say whether surveillance automatically detecting the intrusion or each and everything. It can be one. That's a part of a smart surveillance. Infrastructure, that's especially your other than the buildings, your pathways, roadways, that can be your smart infrastructure that come. Transportation, of course, transportation in the sense is a car. It can be self-driving car, or it can be, or in terms of, let's say, driving cars maybe, or other than the car, I mean to say, let's say this is a smart traffic lights, which can be give rise to, which can have a smart traffic management, right? Basically smart traffic management, because everything is connected by the network, with this internet. And this internet is, so all these branches what you see here, basically these are nothing, these are all are through the all fiber network. So backbone is going to be fiber optic network.
Okay, sir. So, sir, if we talk just about 15 to 20 years back, basically the infrastructure of a city was considered as the physical components of a city, such as roads, buildings, and bridges. Okay, so now how the infrastructure of a smart city is different from that one?
Okay, so this may be okay to answer this. I would say, of course, a building mean like they have to plan. Actually, they have to plan what are the facilities, especially if you look into the health monitoring of a building, right? If you want to health monitor a building, whether this building can survive for 20 years or 25, is there any crack which is propagating? Now everything is in, I would say, in-house, in-house in the sense that let's suppose there is a leakage of water pipe within the house, right? How are you going to detect? How are you going to detect? How are you going to detect, right? So it means you have to place some sensors along the while you're installing the, let's say, water pipe which is within the, let's say, wall, right? How are you going to detect? Now if you look into the, let's say, the electric let's say cable line, so detecting me like, so this is where the technology is coming into the picture. So once the technology is coming into the picture, more technology driven the things, and that's going to provide this, of course it's going to help you, but at the same time it's going to challenge. So other than help also, so both the things are there, so challenges also will be there.
Yeah. And
so it's not going to be an easy. I mean, like, still I don't see that there's any kind of like a worldwide there is any kind of like a city which has been really completely smart city yet.
Yeah.
In US they are trying to do. In India, of course, there's a plan. So like solid, let's say for example waste management, how are you going to do it, right? Waste management, other than your this is a e-waste is going to be a huge issue.
Yeah.
So a lot of challenges, though the life is going to be a bit more kind of like beautiful, but at the same time it will be challenging for us, everyone.
Yes, sir.
So there was a question from where optical fibers are fabricated. So as I mentioned to you, so one is Sterlite company in Aurangabad. So they manufacture optical fiber. Aksh Opti Fiber is there. And Himachal Pradesh is an HFCL, Himachal Futuristic Communication Limited. I think still they fabricate or not, but they used to fabricate. And that's all. The 3-4 companies.
Yes. And so there are few buildings, so like the smart buildings, and there are some buildings that are called as the green buildings. So are these green buildings and smart buildings same, or has some different meaning?
Green means only energy efficient, we to say. What we understand from the green means is energy efficient, but what we understand from the smart buildings is basically having a technology driven, kind of like with the communication between the buildings. So you can have a that's might be, I think, what I understand.
Yeah. And then one more question. So nowadays, lots of smart devices or applications are there in the smart city that require very high speed internet connectivity. So can you please comment on these IoT applications, possible applications in the smart city?
IoT, like in what respect? Basically, let's say if you look into any household, right? If you look into any household, right? Let's say if you let's say in a house, and if you have some devices which are connected through the internet, you have multiple devices, then of course the bandwidth is going to be a challenge there. If each and every device started communicating right with then is going to bandwidth is going to be an issue there also. So I give you certain examples, right? So let's say nowadays very popular, Alexa is very popular among the people. You get the smart bulbs which is coming. Of course, you have to pay a little bit high than the usual bulb. And then other than this, you have the smart refrigerators coming up. So many things, right? Not one, I think many things. And then how you're going to manage? So which information is coming from where? And if you have a sensor, let's say person is sitting, let's say some elderly person is sitting, and then he's having a certain device which is onto his clothes and which continuously monitoring, let's say BP and other things, right? It has to also send the information. So I feel, yeah, bandwidth is going to be a challenge. So that's the reason that we're exploring some alternative bands as well. Other than your C band, we are thinking to have some alternative bands in communication.
Yeah.
Maybe we can be used. Yeah.
Yeah. Okay. Thank you, sir. So, any other questions from the participants?
Yeah,
I think you must have some
I
idea.
think
yeah.
We can talk. I think that's better. We can talk and discuss.
Yeah. So, participants, please.
You can type instead of typing. Also, you can talk if they can from their end. How many of you are using a fiber-based network?
I'm using.
How many of you? Other like who else is using fiber-based network in the participants?
Yes, participants, please.
How many of you using fiber-based internet connectivity? I would say at your place. Say BSNL also giving a solution, Jio also giving solutions, fiber, Airtel also coming with the fiber, Airtel fiber, Jio fiber, and those BSNL fiber. Okay, so he said just a building. What have you seen? I honestly speaking, I think there's one. Just hold on. How to see the chat box is here. What's the recent research, Rakesh, problem in traffic zooming in WDM optical network? I'm not the expert of on this MAC layer optical network, so I won't be able to give you a kind of like a very correct information.
Yes, participants, you can ask from the possibilities
if you have
in
any
smart
other question,
cities, the role of optics in smart cities.
Sensing, and if you have other question, definitely I will be happy. But on to the network side, I won't be able to give you the correct what are the research problem in traffic grooming. Though we use IMPLS and those things, but still, I think a lot of other development. Yes, possible. Laser based, so eye safe reason. If you want to have a communication, let's say a few kilometers, definitely yes. Eye safe means the power has to be so that it's not destroyed. So it might be possible. It can be very strategic point of view. The defense specifically is might be useful. Other than the smart cities. So basically, it's going to be so either 1550 terahertz. Yes, terahertz is problem is the distance. Terahertz can be useful for sensing and detection. So detection point of view is quite, it might be suitable. Basically, terahertz it can go up to the underwater communication, or which one you mean to say? We don't use any right now. I think only this laboratory scale is going on. There is no kind of like commercialized. So only it is a laboratory scale. We use basically visible side. We use the visible spectrum, basically the green or blue, and that means you need.
Sir, as lots of applications are increasing in smart cities. Okay, so there must be more energy consumption, or we can there must be the release of the CO2 or other hazardous gases. So basically, that is stopping to make the smart city, because the smart city must have the user-friendly environment. So then, how to deal? Can you please comment on that?
I think we are going to first monitor. That's why I'm saying air pollution, each and everything has to be there. Sensor has to be installed to detect the ppm scale level, ppb scale even. Whether if we can find out, so that's a challenge for the sensor community as well. So detecting at the small scale, ppb scale is of course is a challenge. But electronic sensor, then again you will ask the life of those sensors. Right, the end question will come of the life of those sensors. So I think people are working on this. Indian cities are not. I would say infrastructure has to be there. Not yet. We are not ready. Those antenna other things are there. Some people all companies are gearing up. Especially if I think Jio and Airtel is gearing up for infrastructure has to be ready. Hardware.
Yes.
Yes, it will be fully optical. Is already, I think, as far as I know, that is Geo network, basically all optical. And DWDM, BSNL also DWDM. I'm not sure about the Airtel, I think, but all optical. All optical is. And regarding this VLC hardware part, design link, you can just, I think, find out certain books onto the CRC. There is a book onto the visible light communication. You can have a look. Hardware part is basically see whether if you want to use a white light, which is used for lighting into the house, you can use it, right? But if you want to use certain other application, other wavelength band within the visible, is possible. Why we are sticking onto this less than 1 micrometer visible is we can use that bulb is on that LED material, and we can use the detector, which is again silicon based technology detector part. So it's a cheaper.
Yes. Some more questions from the participants. Still, we have 10 minutes. If you want. It's a very good opportunity to interact with Professor S.K. Varsane right now. So you can interact with him.
Hello, sir. Good afternoon, sir. Hello. Sir, actually, I was asking regarding the VLC. Actually, sir, there was one question in my mind. I just want to work in this direction, but particularly the problem which I was facing is how to start, where to begin, because I contacted the IIT Delhi and IIT Madras for designing this part, because I have seen some companies like ERNet has worked in this direction in association with IIT Madras, designing a VLC link. They have designed a VLC link in this direction. I have contacted them because I want to work in this direction, and I want to do some. I want to take some fellowship or some grant for this purpose, so that I can start my research work. So, sir, can you put some light in this direction? How should I begin with the things so that I can put a proposal? And
so, since we are looking hardware part, so
yes,
we
sir.
did in our lab few years back some hardware development. We did it. So we started with the simple circuits.
Okay.
Electrical circuit we started, and then we had a simple LED bulb which we bought from the market. right? It was simple LED bulb, and then we just put the information to the bulb and retrieve with the detector part. Detector is a very simple. You can buy silicon-based photo detector in market very cheap as well. It's not so you can start with this. So only thing is what you can look into the since is within, if you see within a, let's say internal within a house, right? Let's say if you are trying to communicate within a room, right? In that case, you can see the kind of effect of the, let's say, presence of other objects that you can have a look. You can identify basically also non-line of sight. You can try out whether it's possible or not. One option, non-line of sight also you can try or see. And if you see the external one, then in that case, there's a kind of lot of things in the sense atmospheric turbulence, and those study can do it.
Okay, sir.
But
Sir,
that's
actually,
it's not going to be long distance.
okay, sir. Actually, I was planning to do in my home regarding this wireless inside my home. So I just gone through the optic system where actually there was some simulation work was there in which there is some data and there will be power distribution. You can see inside your house or room where you want to check or send the link. So, sir, is it compatible that I can do the simulation part in the office system where I can see the light distribution parameters and check according to that what is the distribution and then plan to communicate accordingly? Is it possible, sir?
Yeah, it's possible. In that case, you need to have a light sensors. You want to see the lighting condition, you need to have a light sensor. I think those also very available, like transistor base. I think light based transistor, so you can just plug in and that you have to just modulate. That's all. I think it might be possible.
Okay, sir. Okay, sir.
Yeah, FPGs are people we are using fiber grating as a sensor. So basically, for the this for especially strain and temperature sensors, people are doing FPG. Other those also it can be used for different applications, fiber gratings. And regarding this recent laser sources that have shown promising properties, in the sense can be more kind of like what you want to get it. Right now, the target is to get it the laser sources, laser diode for telecom application, which has a very narrow line width, if can possible, so that the dispersion can be minimized. Like dispersion basically comes because of source. Source has a certain bandwidth, and source has certain bandwidth means you have multiple wavelengths which is traveling in the fiber, and that makes a group of waves that travels through the fiber, right? So you need to have a narrow line width sources. That's one kind of challenge. So people are looking. Other than this, people are also looking kind of like a sources which can be COM based or supercontinent based sources, might be useful for telecom.
Any more questions? So I think
feel free to if they have any questions, feel free, they can ask, like still if you have any doubts, so then I can just go into the last slide if you want, for me. So what we are just to what we are working. Yes.
Sir.
Yes.
Actually, I was planning to.
Your voice is I think not very clear. I
Hello?
think yes, please
Yes,
tell
sir,
me.
can you hear me? Sir, actually,
Yes, we can hear.
Sir, I was not able to interact. I just sent the emails to IIT Madras, and I was not getting a response. But I was planning to, sir, start designing of the VLC link inside my room or checking the lighting. Sir, in case I find some any difficulty, I can mail you. Sir, is it possible?
Yes, you can. You can send me an email. No issue.
Okay, sir. Okay, sir.
Right. So here are the things on from my side. What we are right now working on to the different aspects. So I think I can say on to this. We are trying to create certain devices, fire based, especially for the, as I mentioned, few mode fiber based devices, basically multiplexer, demultiplexer. So we're trying to make certain sensing based on these devices as well. And then on the this is another one is on the meta materials based certain basically devices. And on the communication, we did some work, as I mentioned, to Wi-Fi. I think few years or 3 years back, we created a link within our lab So where we could transmit the information, and underwater we have done already certain experiment. We can go up to the 2 Mbps for around 1 meter of the tank length. We did the experiment onto the only tank. We have the water tank like aquarium, the 1 meter, and put up the transmitter and receiver is there, and then we put up the water, and then we could reach up to the we could transmit the video, we could transmit the data, we could have the data, we could transmit the video through the water. So to 2 Mbps. So of course the challenges are there, especially onto the signal kind of recovery. A lot of challenges are there in this. So that's on, and I think all of you might be knowing that's your 2015. This is International Year of Light has been declared by United Nations. So that's also because of this technology. This is going to be playing a very important role, whether it is in a communication or energy, manufacturing, healthcare, sensing, or defense, and many more. So this is the last slide from my side. I have my email ID. Both email ID is mentioned. My official email ID as well as my personal email ID. Both are mentioned here. So you can, if you have any doubt or any questions, you can put me an email as well. And thank you for your kind attention. If you have still some question, you can ask some question. Are you able to see my slide, right?
Yes.
Last one, you were able to see. Okay.
Yes, it is visible, sir. Last one.
Okay. Okay, good. So it is, you can, this is my email ID. Yes.
Yes, sir. Sir, actually, you did Li-Fi work 3 years back, particularly. So, what was the actually data rate which you have transmitted, and what was the distance which you have worked on?
I think it was a 2 feet. We wanted to put up the things into the roof, but by the time the student has left, and we didn't progress further. We tried to we were trying to make the communication under NLOS, non-line of sight.
Okay, sir. Okay. And how much was the data rate, sir, in that? Do you remember?
Data rate was not very high because it's so completely limited by the circuit. And of course, since it's an LED, so it is not going to be that very high. If it is a laser, you can go GBPS, of course. And if you have super LEDs, then it might be possible. Since we are using simple ordinary bulb, white light, white LED, so data rate won't be that high. You can go up to Mbps. You can achieve 3 Mbps easily.
Okay. Any other question?
Did you get my? Yeah. You can achieve 3 Mbps very easily with the white LED. Tens of Mbps totally depend on circuit on transmitter side and the receiver.
Okay. Okay, sir.
So receiver
sir, I will mail you. Yeah, sir, I will mail you my details. Is it possible, sir, that you can share that details so that I can see?
I can share that information.
Yeah. Thank you, sir. Okay. Thank you, sir.
Okay, good.
Yes, so I think there is no question from the participant. So, sir, I would like to thank you once again for delivering such an interactive and informative lecture that basically gives us the idea where this optical communication plays an important role for developing the smart cities. You have given us various dimensions where we can work upon the components where we can think upon. Okay, so thank you, sir, once again for accepting my request and for delivering this interactive and
thank you, Amit.
Thank you,
Yes, thank you, everyone. If you have any question, you can put up email. I think already in the slides, so you can ask. They can ask me. I can just put up the message as well. Okay, take care. Thank you, Amit.
Thank you, sir. Thank you, sir.
Bye.